Well, we couldn't be more excited to be with you today and to have individuals leading many of the important organizations, if not among the most important organizations in the world. So with us today is Nancy Brown, CEO of the American Heart Association, the greatest achievements in extension of life in the United States and other parts of the world in the last 20 to 30 years have occurred around improvements in treatment for heart disease and stroke. And the American Heart Association, led by Nancy, has been at the center of those efforts. Nancy, thank you for joining us today. Also with us today is Tom Frieden, Director of the U.S. Centers for Disease Control and Prevention. There isn't a day that goes by on the front page of some issue in the world that really does not touch what Tom and the Center for Disease Control is addressing. If they're most successful, it's in the prevention area and it doesn't occur. Unfortunately, sometimes when things occur, we're lucky they spring into action. Tom, thank you for joining us today. With us today, between Tom at the CDC, Francis Collins, who runs the National Institute of Health, probably the most important organization in the world dealing with disease and will ultimately lead to increases in the quality of life and the extension of life. Dr. Collins, thank you for joining us today. And Dr. Andy von Eschenbach, who, in response to the President's call, head of the National Institute of Health, head of the Federal Drug Administration, FDA, and today at Samaritan Health Initiatives is an advisor to countries throughout the world and organizations. Dr. von Eschenbach, Andy, thank you for joining us today. In September of 2012, as a follow-up to the March of 1998, we put on the Celebration of Science in Washington, D.C., bringing 1,200 people from around the world to meet in Washington to recommit to the importance of bioscience, whether it was food, whether it was environment, whether it was energy, or whether it's the challenge of bioterrorism. Why does science matter? We prepared a couple-minute video here for you to see.
In the 14th century, 1/3 of the population of Europe, nearly 25 million people,
died from the Black Plague. Smallpox killed an estimated 400 million people
worldwide in the 20th century. And tens of millions of people throughout the world have died from cholera. As a result of these epidemics, worldwide life expectancy was
grim. A baby born in 1800 could only expect to live an average of 26 years, and that number only rose to 31 years by 1900. The United States was not immune.
1 in 5 children born in America in 1900 died before the age of 5.
And the Spanish influenza of 1918 killed more than 600,000 Americans in a single year.
But the combination of improved sanitation and the discovery of more than 24 life-saving vaccines and the widespread use of antibiotics
drastically reduced the rate of infectious diseases and resulted in a sharp drop in infant mortality. Other significant medical advances of the 20th century include the discovery of insulin to manage diabetes,
the use of radiation and chemotherapy to treat cancer, the advent of the kidney dialysis machine, and the introduction of the cardiac pacemaker.
By 1950, life expectancy jumped to 49 years, allowing people around the world
to lead more productive lives. James Watson and Francis Crick's discovery of the chemical structure of DNA in 1953
eventually led to a greater understanding of Alzheimer's, cancer, diabetes, Parkinson's, and many other debilitating diseases. Less than 40 years later, thousands of scientists from around the world
joined forces on the groundbreaking Human Genome Project, financed by the National Institutes of Health, the Department of Energy, and the Wellcome Trust of London. This 13-year, $3.8 billion project has already started to revolutionize
the way we diagnose, treat, and eventually prevent more than 4,000 genetic diseases that afflict people across the globe. The economic benefits have been equally astounding. The Human Genome Project
created thousands of jobs and generated an economic impact far exceeding the original investment. Bioscience investments also hold the promise
of helping solve the most significant global issues of the 21st century, including access to clean water, food production, defense against bioterrorism, energy supplies, and environmental sustainability.
Investments in science have saved millions of lives and have had a profound effect on our quality of life. Worldwide life expectancy is now 67 years.
While in America, it's near 80, giving people everywhere the invaluable gift of more time with loved ones.
We have witnessed remarkable achievements over the past century.
But the potential for innovation is now greater than ever.
The American people have made major investments that have brought us this far.
We cannot afford to put the brakes on this engine of progress.
Now is the time.
Now is the time.
Now is the time.
Now is the time to renew our commitment to bioscience.
We had many objectives at the celebration of science. One of them was to reaffirm the commitment to the bioscience and recognizing that we are at the forefront of an entire revolution in science. The United States has made an incremental $200 billion investment through its federal agencies since the march in 1998. Unfortunately, we have not increased, and adjusted for inflation, we have decreased our investment in the biosciences. Francis, the opportunities are great in front of us. We recognize today that you've never been constrained as much as you are today in investments. And one of the areas that we focused on was young scientists. Most of the great discoveries have come from individuals within 5 to 10 years of them being in school. Whether it was Albert Einstein or Newton or others, they were at the young age, and in Washington, on the stage at the Kennedy Center, we gathered 100 of the world's leading scientists who have all studied in the United States, and most of them still remain at institutions at the United States, to send a clear message to the political leaders of the world of their importance. Yet, Francis, their opportunities are less today to be funded, and our question and our quest to get people interested in STEM education, that group of 100, their journey, those young investigators, they've gone a journey that they're now 35 and 37 years old. Francis, what would you say to a young scientist, and what are some of the challenges? And Francis, could you tell us why you're so excited about the future?
Well, first of all, let me say it's great to be on this panel. It's great to have been here for these 3 days of really remarkable presentations, discussions, both in the conference rooms and in the hallways. And Mike, you've done a real wonderful thing by giving all of us the gift of being able to be part of these conversations, and it's much appreciated. I'm right where that little boy was who said the potential for innovation has never been greater. I was like cheering because it's true. Whether it is basic science discoveries like the new Brain Initiative, which is going to give us the ability to measure hundreds of thousands of neurons functioning simultaneously and figure out how the circuits in the brain work, or whether it's the use of genomics to be able to uncover answers to rare diseases that previously we had no clue about, and then lead on towards therapeutics. We might talk about cystic fibrosis as an example at one point. Or whether it's our opportunity to build new partnerships with the private sector, with foundations, with other government agencies. We are at a remarkable moment in scientific history. And yet, as Mike said, we're also at a remarkable moment in terms of the uneasiness that our most critical resource is experiencing. And you saw that photograph of all those people gathered on the stage at the Kennedy Center. Those are the people that we should be most worried about. This next generation of scientists who are going to lead the charge and continue America's wonderful story, or perhaps not, if we're not able to come up with ways to keep that engine running. And in fact, the circumstances right now are challenging for those folks. I spent last weekend in Chicago meeting with the MD PhD students that are part of the American Physician Scientist Association, an incredibly bright, gifted group of young men and women who have basically dedicated with passion their lives towards the next generation of discoveries that are going to change the world in terms of medical benefit. And I love going to those meetings because these are people of such vision, and they're so excited about the science that they're doing. But this year was different. They'd heard about the sequesters, and they'd also realized that NIH funding and funding for science in general has been gradually trickling back over the last 10 years. And they look at people just ahead of them who are having difficulty keeping their labs going, and they're wondering, can we stick it out? If you show the slide about what's happened to grant success rates over the course of just the last few years, that would be slide 12, it'll sort of make it clear why there is such a tension in this particular community. That's what you can see there. If you're an applicant out there with a great idea working in one of our nation's finest universities, and remember, NIH money goes out to all those universities, that's how we do what we do. Over the course of the last 50 years or so, on the average, about 1 grant out of every 3 would get supported. But now, over the course of the last 10 years, as inflation has eaten away at flat budgets, that number has plummeted to well under 20%. And with the sequesters, where we lost $1.7 billion in one fell swoop a month ago, it has fallen probably to more like 10% or even less for some new applicants. That is not sustainable.
Let's talk for a moment about success. We're going to celebrate science today.
Yeah.
And at the NIH, we brought 1,000 people. And I know you had the Berry twins and their parents there. Could you tell us that story?
I'd love to tell you that story. So maybe we could get the video ready to go here. So let me tell you about the Berry family. This is a family from the West Coast, and the 2 twins that were born to this family, Noah and Alexis, appeared okay to the docs at birth, but their mother knew something wasn't right. They seemed neurologically a little floppy, and over the course of the next few years, they became successively more impaired. By the time Alexis was 6 years old, if you can pull up that video, it's at the very end of the whole set, she was clearly encountering some significant difficulties. Here's a video of her talking to her mom. And this progressively got worse and worse over the years. Empirical therapy was tried. She got some benefit from L-DOPA, a drug that's used for Parkinson's disease, but she began to get in more and more trouble, as did her twin brother, Noah. Her parents sought every kind of medical advice they could get. They went to see dozens and dozens of experts. There was no diagnosis, and finally, they approached the Baylor College of Medicine that agreed to do a genome sequence on the twins. And what they found, remarkably, had never been described before. A single letter out of place in this 3 billion letter genome that was resulting in them being unable to synthesize normal quantities of dopamine, hence the result that they had seen from L-DOPA, but they also couldn't make another neurotransmitter, serotonin. And by simply giving them in their diet an amino acid called 5-hydroxytryptamine, they could make their serotonin. And let me show you now the video of what happened within a few weeks after starting that new therapy from kids that were in wheelchairs. Can you show that last video? That's Noah and Alexis. Alexis is now running varsity track.
So the human genome sequencing, a project that Francis led, $3.8 billion investment, 13 years, 1 letter out of order out of 3 billion. Today, a couple $1,000 in a couple hours, and someday it'll be hundreds. We can lead to precision medicine. And that story that you just told us, I'm assuming, Francis, we're going to see repeated time and time again.
We will and we must for that.
Andy, if you were running the National Cancer Institute or the FDA today, what would you be telling the American people because today you have a lot more freedom since you're no longer running the National Cancer Institute and the Federal Drug Administration, about the absolute cut in funds and what appears to be a lack of understanding by the American people and some of our leaders of the importance of these organizations.
Yeah, I did basically ask them to just pause for a second and think back 100 years ago to where we were at the turn of the 20th century, and science and technology was unraveling the secrets of the atom and its nucleus. And it changed our world forever. It changed civilization forever, from atomic energy all the way through material sciences to our understanding electron, and here we are. Well, put yourself in this position now, where we have shifted our emphasis from not just the atom and its nucleus to now the cell and its nucleus. And because of the work Francis has been alluding to, we're unraveling those secrets. That knowledge is changing everything. You heard about the impact on medicine, agriculture. Yesterday, Vice President Gore talked about spider silk goat. Well, there's sumo salmon, and there's also tuna pig, and on and on and on. Francis's colleague, Craig Ventnor, is genetically modifying algae for fuel. And Tom's concerned about some of the problems with bioterrorism and weaponization of biological material or pandemics. And so we're seeing the life sciences change everything. And this is our moment to seize that opportunity. And we're beginning to look like we're missing it because we're not willing to make the commitment. Francis just alluded to the commitment to the young scientist, bringing people into this. And you know, it's not just a matter of numbers. We don't just need more people. Interestingly enough, if you look at the fact that biology is now a digital science, these young people are bringing skill sets along with them that we don't have and we can't even teach. They're teaching us. So if we lose them in this pipeline, it's not just a matter of numbers. It's a matter of losing essential skills to lead the 21st century in a revolution in life science.
How does it strike us at home, to each one of you in your own home? 1 in 2 men will get cancer in this country, 1 in 3 women. In the 1950s, it was polio. Polio was declared an epidemic in the United States in 1952. In 1950, we estimated by the end of the century we would be spending $100 billion a year to deal with polio. In the early 50s, they started to map out to build iron lung hotels to keep alive polio patients. A young 30-year-old, Jonas Salk, who's got money from the March of Dimes, by 1955 had developed a Salk vaccine. Effective, potent. Polio is conquered, but we needed people to be able to take the polio vaccine. They recruited at the time the most recognizable American. They went to him and asked him if he would take the polio vaccine so they could use him as the poster boy for the country. He agreed, and Elvis Presley on national television got his shot immunizing him against polio. Polio today, estimated, and Tom could give us a better number, cost about $100 million, so they were off by its 1,000th of what people had estimated. In the 1980s, there was another epidemic in America that we were concerned about. It was AIDS. And here in Los Angeles, a young woman named Elizabeth Glaser received HIV from a blood transfusion. And unfortunately, it passed to her daughter and to her son. And she formed the Elizabeth Glaser Pediatric AIDS Foundation. And my family foundation and others joined with Elizabeth Glaser to focus on pediatric AIDS and what we could do so that it was not passed on. Athletes, entertainers joined in that effort. The world was shocked in 1987 when Oprah Winfrey went on television and told us. Let's take a look at what Oprah said, 1987.
Hello, everybody. AIDS has both sexes running scared. Research studies now project that 1 in 5, listen to me, hard to believe, 1 in 5 heterosexuals could be dead from AIDS at the end of the next 3 years. That's by 1990, 1 in 5.
So you can imagine why a parent didn't want a child to go to school with a person with HIV or AIDS with that type of announcement. But even more so, the world focused in 1991, 4 years later, when Magic Johnson went on television.
Because of the HIV virus that I have attained, I will have to retire from the Lakers today.
The day that I heard about Magic, it just sort of changed my love for basketball. It shook me up. You know, you get that feeling, probably the same type of feeling I had when my father died.
Caused me to, you can almost hear both of us with some tears in our eyes. And I'm choked up because he did call me. And when something happens, to you, and then you find out who really your friends are and people who really care about you.
So it's 22 years later, and Magic Johnson was here alive and well and outgoing and smiling and as active as ever. He also was with us at the Celebration of Science last September. David Ho, who's devoted his life in this area, and Tony Fauci was with him. But these are the type of issues that we face every day if we're working for the Center for Disease Control and working for Tom Frieden. Tom?
Thank you so much, and thank you for having this. It's such a wonderful opportunity to learn from each other and think about what more we can do. At the CDC, we work 24/7 to protect Americans from threats, whether they're infectious or non-infectious, whether they're from this country or abroad. From the early 1980s through 1996, I practiced medicine in New York City. I remember Magic Johnson's announcement, and I remember the galvanizing impact it had on my patients. But until the NIH came up with new drugs, it was painful for us to try to care for people because there was so little we could do. The CDC's space is going from the product to making it a reality, whether that's polio eradication with Bill Gates galvanizing that effort, and now we're so close to the finish line, and we can talk more about that. But in HIV, to go from understanding that it's possible, theoretically, to treat people effectively and drive down the likelihood that they'll get sick or pass it on to others by 96%, to making that a reality in this country and around the world. Prevention is our space, protecting Americans from threats. And I have to give tremendous credit also to the bipartisan consensus on critical issues, including polio and HIV. In polio, we've been working since 1988 to eradicate polio from the entire world. In 1988, there were about 350,000 cases of polio in the world. In 2011, there were 650 cases. In 2012, there were about 223 cases. We're down to 3 countries that have never eliminated polio. We're down to fewer types of polio in fewer places in those countries than ever. And we can get over the finish line, but that last mile, like a marathon, is always the hardest. So the commitment is so, so very important. And you know, eradication, not every disease can be eradicated today, but polio can be. Smallpox was with CDC and WHO leadership. Eradication is the ultimate in both sustainability and equity because it's for everyone and forever. And in HIV, we also have a tremendous bipartisan consensus. The PEPFAR program started under the Bush administration is resulting in the treatment today of about 5.3 million people around the world. They're teaching, they're learning, they're contributing to the economy, they're raising kids, and if it weren't for PEPFAR, they would be dead or dying. Last year alone, more than 250,000 people, more than 250,000 babies in the world were born without HIV because of PEPFAR. So these programs can absolutely change the world, and they can protect ourselves as well. How many people in this room have had measles? Show of hands. Measles? How many people in this room under the age of 40 have had measles? Very few, because until recently, measles was almost universal. And while you might think of it as a mild childhood illness, until recently it killed 1 million kids a year. In the last decade, we've been able to scale up measles immunization around the world, and 4 million fewer kids died from it. And we still are at risk because we're all connected by the air we breathe. So last year and the year before, we've had hundreds of people come back to this country from areas of the world that still have measles. And just to contain the situation, to hospitalize them, to care for the people around them, we have had to spend millions of dollars protecting the world from health threats like measles, like polio, like HIV. Not only protects ourselves, but it also promotes economic growth and equity, and it burnishes the name of America in what we do around the world.
I think Tom has made an extremely important point, and one of our 8 goals at the Celebration of Science, which Tom has so eloquently just addressed, was to let the American people and let the leaders of our country and let the people of the world understand that the trillions of dollars of foreign aid from America over a long period of time have made fabulous contributions. But there is no greater contribution than the extension and the extension of life and increase in the quality of life. And when we focus on these areas such as Africa, South Asia, Southeast Asia, the enormous extension of life that's occurred, as Tom has just pointed out, the economic development, the fact that a woman in sub-Saharan Africa does not pass AIDS on to her children. One that allows her to be a mother, allows the children to have a healthy, longer life, and the proper treatment allows her to have a healthy, longer life, spurs economic development, and this is probably America's greatest contribution to the world, and as Tom has said, not just today and the future. One of our other goals at the Celebration of Science was to underline the importance of the disease-specific organization. They have become far more sophisticated, and in some cases they've helped fund clinical trials. They've been able to bring pharmaceutical companies together in pharma and academic science centers and government agencies, and they've served in this role to accelerate science and educate individuals throughout the world. One of the greatest of these organizations is led by Nancy, American Heart Association. Nancy, as the CEO, has had a lot of responsibilities, but it's quite unique today when you think about it. All these achievements, Nancy, that we've had and made, and I'd like you to talk to about it, the relationship with science. But today we have even greater challenges because of the gaining of weight and the challenges in society. Nancy, I know you've been with the American Heart Association for more than 20 years. Take us through that journey, which has resulted in the extension of life and the improvement of quality of life for Americans and those around the world.
Sure. Mike, thank you. And let me echo Tom's comments to thank you for this wonderful, wonderful gathering. You know, when you want to talk about celebrating science, you need to look no farther than the advances in cardiovascular disease and stroke science in the past 40 years. If we could put up slide 16 quickly, you'll see the amazing advances in science related to cardiovascular disease and the resulting reduction in death rates of Americans because of these advances. So you go back to things that we take for granted today. You know, you have a blocked artery and you have angioplasty, or drugs that we take for granted today. These all came about because of science and our investments in science through the NIH and our investments in science in organizations like the American Heart Association. And so we're very proud that over the past 40 years, death rates have decreased every single year. Death rates from heart disease down 36% just in the past decade alone. However, we have a crisis looming, and that is the increase of the poor health of Americans due to our lifestyle largely. Back a couple of years ago, the American Heart Association created a metric of what we call ideal cardiovascular health, the 7 health factors and health behaviors that would define a person's ideal health and health status. Those things include not using tobacco, getting appropriate levels of physical activity, making sure your body mass index is appropriate, controlling blood pressure, blood cholesterol, blood glucose, and of course, absence of use of tobacco. And when all of these come together and a person is doing everything just right, in our words, they have ideal cardiovascular health. Here is a startling statistic, and this applies to everybody in this room. Fewer than 1% of all Americans are in ideal cardiovascular health as we have defined it. 99% of the people in this room do not have ideal cardiovascular health. And the call to action for you, and it certainly is for us as well, is what can we do to reverse these trends? You know, for the most part, children are born in ideal health, and it's their lifestyle and the environment in which they live that changes that over the course of their lifetime. And we know that if a man, for example, reaches the age of 50 in ideal cardiovascular health, his chance of having a cardiovascular event in his lifetime is less than 5%. And so we really, Mike, have mobilized the work of the American Heart Association to continue to value and promote and fund young investigators so that they can go on and be active recipients of NIH grants. But we have to get ahead of these lifestyles, and we are focusing on that through changing environments and inspiring Americans to care about their health and change their behaviors.
When we look at the health issue, and let's maybe divide it into 3 parts, Nancy. If we start, we're looking at wellness and prevention, and every single person on this panel would rather address these issues in a wellness prevention standpoint than have to move to treatment and care. And 40 years ago, when we started our efforts in philanthropy, 90% of the money or so was being spent on treatment and care. Unfortunately, 40 years later, most of the money, almost 90% of the money, is being spent on treatment and care. And if we could deal with the prevention and wellness element, we would be successful. And likewise, as we saw in polio, the solution was research and cure. And when I look back, Nancy, over this period of time, and Tom and Francis and Andy, I can tell you, particularly in the last 20 years, in spite of everything we've done, in spite of speaking to you for the last 16 years, at the global conference, we have not made progress. Excuse me, and it looks like, based on the work of Ross Duvall at the Milken Institute, that it costs the United States $1 trillion a year. Imagine how we could deploy that money at the Centers for Disease Control, the National Institutes of Health, if we weren't spending this money to deal on just the change in weight in America. So what was a problem in 4 states, as Nancy has outlined, exists today in all the states in America. And America today, of all developed countries, is the heaviest country in the world. So this science community we have has found ways to solve the problem. And unfortunately, we've delivered back to you, Nancy, a less healthy company. So I went and visited the county fair, saying, okay, we've been talking about food. what's going on? What are the new foods that might be coming out this year?
Oh, yeah.
So here is the county fair.
Oy.
You were concerned you weren't eating enough bacon. We were concerned, so they have now offered you chocolate-covered bacon this year. And chocolate-covered corn dogs. And the one that I was really surprised on, you know, not many people like just going and getting a quarter of a pound of butter out of the refrigerator and just eating it. So they've found a solution to that problem. They will deep fry the butter now, and you can just have your quarter of a pound of butter on a stick. Now there's a couple here that I really was excited about, just decide one if we put that slide back up. And that one that I was excited about was, I always wondered what happens to bacon grease. You probably wondered that yourself. Now we know. You can get the garlic butter bacon fries fried in bacon fat. Okay, that is where it's gone. Okay, or deep battered bacon, etc. So all this discussion of now nutrition and vegetarians increased, but when we look at the new foods being introduced, they are a challenge. Now, Nancy, there's a relationship, I know, between heart disease and diabetes. What is that relationship?
Well, clearly, diabetes, elevated blood cholesterol, is a risk factor for cardiovascular disease. You are more likely to have a heart attack or a cardiovascular event if you have type 2 diabetes. And certainly, unhealthy foods like those at the State Fair and in many other locations are adding to the increased number of people in this country who are obese and who have elevated blood sugar levels. And that is really a problem for the future.
Let's talk about partnership for a moment. When we think about cystic fibrosis, Francis, you played a major role in these developments. And it was a partnership by taking the human genome and sequencing, and you're going to, a for-profit biotech company, and Vertex, the cystic fibrosis. And so when we looked at it, it started with this idea of DNA with Collins and Crick. I'm putting you back in the place of Jim Watson there.
Whoa.
But really it was Watson and Crick, which led to the sequencing, which led to Dr. Collins, which led to the Cystic Fibrosis Foundation, which essentially led to Vertex, and eventually led to the patients. Could you talk about that sequence for us and that partnership?
Well, it's a wonderful story, because at the moment there are some very happy outcomes, and we hope more to come soon. Cystic fibrosis is the most common potentially fatal recessive disease for individuals who come from Europe, affecting about some 1 in 30,000 people. And until about 30 years ago, we had no real understanding of it at all. I had the privilege of leading a group in the late 1980s when I was at the University of Michigan, and collaborating with a group in Toronto because we figured we could go faster if we worked together, that found the cause of cystic fibrosis in 1989. Initially, the hope was that this could be treated with gene therapy. It turned out to be very difficult at that time to be able to replace the missing gene using gene therapy in the airway, which is where the disease causes its greatest risks of death. And so the Cystic Fibrosis Foundation, a very visionary group of advocacy and scientific experts, decided they would make a big bet, a very risky bet, on developing small molecule therapies for a disease like cystic fibrosis. And most people thought, that isn't going to work. You have something that isn't working and you're trying to replace it. Usually small molecules, you're trying to stop something that's overactive. Here, this was trying to compensate for something that was underactive or missing. But they moved forward with this with a great deal of support from the public and families with the disease. And it linked up with what was originally Aurora and then became Vertex, a small company, and came up with an idea about how to screen through hundreds of thousands of possible chemical compounds, think of them as molecular shapes, to find one that might actually have activity. And over the course of many years of very hard work in an area where most people said, oh, I don't think I want to invest in that one, they came up with some promising compounds. Those then ultimately, after safety testing, went into clinical trials. And just a year ago, to the great joy and delight of all of us, one of those, Kalydeco, was approved in record time, I might say, by the FDA. This drug is almost miraculous for the 4 or 5% of patients who have cystic fibrosis with a very specific misspelling in the gene. Unfortunately, it's 4 or 5% because most people with cystic fibrosis have different misspellings. But for those individuals, there are stories of people who were on the lung transplant list, essentially bedridden on oxygen all the time, who are now back at work because of this therapy. And I'm glad to say there are 2 other drugs in phase 2 and phase 3 trials that, if they are successful, will work for 90% of cystic fibrosis. That is a great story. What's not so great about it, of course, you will be quick to point out, is how darned long it took. 1989, knowing what the cause was, 2012 to get the first drug approved. We have to speed this up. And so one of my agenda items of highest priority with my colleagues at NIH is to try to figure out where are the bottlenecks in this long drawn-out pipeline? Why does it take on the average 14 years? Why are the failure rates so high, 99+%? Why does it therefore cost so much? And this is the reason why we've started this National Center for Advancing Translational Sciences, or NCATS, to try to knock down some of those obstacles. And we are very excited that that is beginning to bear fruit with new ideas of using technologies that weren't applied before to do drug safety testing using biochips instead of animals, to convince companies that have compounds in their freezers that didn't work for disease A but might actually work for disease B, that they could make those available, and we could crowdsource the opportunity for repurposing compounds that we already know are safe in people, and therefore skip over years and millions of dollars that otherwise would be necessary for disease B. All of these things are happening now in a way that probably couldn't have a few years ago. We're impatient, and yet I think the chances now of successes like cystic fibrosis are going up very steeply.
Andy, you were there with us on the steps of the Capitol in 1993. As a slightly younger scientist, prior to becoming a head of the National Cancer Institute and Federal Drug Administration, and worked, I know, on partnerships. And one of our goals has been, and the messages of the Celebration of Science, was partnerships. Partnerships among agencies, partnerships between different type of institutions, partnerships with disease-specific organizations was that goal. Talk to us about these partnerships, and also on an international basis that you try to foster and that you believe are a potential, not just between agencies in the United States, but around the world.
Yeah. Well, clearly, Michael, success here is going to be a team sport kind of activity. And Francis just showed you that timeline for being able to bring these products from discovery all the way to patients. That's an incredibly important area, even for the collaboration that has to occur among federal agencies, because, for example, FDA plays a very important role in that process, not just with regard to being able to make a decision on review, but actually playing a role in the total life cycle of that product development, so that the discovery that Francis is driving is really aligned with the product development, and that's aligned with the regulatory expectations. So we don't have these potholes and these speed bumps that frequently frustrate people who are trying to bring products to patients. The second part of the collaborative effort, over and above that, is the fact that what we are appreciating is the fact that these complex diseases, be it Alzheimer's or diabetes, et cetera, cancer, they're invariably going to require the integration of components to make up a solution. So we've been living in an era where we've been pretty much working independently. Drug companies who make drugs, others who make biologics, others, for example, who make devices. And what we're seeing now is the need for, even at the beginning of the process, conceptual collaboration as to how to put those parts and pieces together. A simple example right now that's emerged is, of course, the integration of diagnostics and therapeutics. So the collaborative effort that's going to be required there. And then most importantly, the one that you were alluding to is the fact that these diseases, these problems are global. Their solutions are going to have to be global. We now have tools for data integration, data sharing that makes global integration and collaboration much more feasible and practical. And we need policies to drive that. So for example, when I was at the Food and Drug Administration, it was clear that much like what Tom has done at CDC, we needed to get beyond our borders. We needed to begin to work collaboratively with countries like China and others around the world to build capacity. So we opened FDA offices in China and India and Central America and the Middle East, and even strengthened our ties with Europe. So collaborative effort, even at the outset, the conceptual outset of creating solutions, is really going to be a critical element of success.
Tom, I want to turn to you. You know, we read on the front page about SARS. We read on the front page about a flu in birds someplace in China. And today, I think, after AIDS and other diseases, Americans and everyone around the world realizes that it might not be limited. As you've discussed, people can get on an airplane and fly anywhere today. How does the world look to you, and how does the CDC? So your mission here of protecting us and preventing these issues, okay, what do we look for from you in this area?
Let me illustrate that. Could I see a show of hands? How many people have been to China in the past 3 months? Just raise your hands. Great, and would you mind terribly just standing up for a minute, those who raised their hands? Just for a minute, just for a minute. If you've been to China, stand up. In the last 3 months. Anyone been to Taiwan in the last 3 months? Can you raise your hands or stand up? Now, if you look at the people standing, if you have been within earshot, just stay standing for a second. If you've been within earshot of them when they've coughed, if you can stand up for a minute. If you've been in earshot of them when they sneezed, can you stand up? And if you've been within 6 feet of them at any time in this conference, could you stand up for a minute?
So you have the whole room.
Exactly.
Now, if your last name begins with B, C, G, L, or P, stay standing. That's about 20% of the alphabet. All of those people still standing could be dead. Influenza has enormous capacity to kill. 1918, 50 million people around the world. You saw 600,000 in the introductory section here. H7N9 is avian influenza that's better adapted to mammal lungs than any avian influenza we've seen before. It causes rapidly progressive disease. It's killed about 1 out of every 5 people who it's affected in China. Now, fortunately, so far, it's not spreading efficiently from person to person. So this particular strain is not going to cause that pandemic. But only the mutation of a few different loci within the virus could. And this virus doesn't make birds sick. Previous bird flus have made birds sick so we could cull flocks and stop the spread. I'd like to just tell you 5 things you should know about CDC. First, China would, in all likelihood, not have identified this strain of flu had it not been for the work that we've done with them for the past 10 years. We helped them gain the technology to track, to do laboratory tests for, and actually to be certified by the World Health Organization as a global reference center for influenza. And what that means is that within hours of receiving the virus, receiving the samples, they had identified it as a new virus, and they had posted it on an international system so we could download it, and anyone in the world could download it and immediately begin to make diagnostics and vaccines against it. That would not have happened had it not been for SARS and the Chinese government realizing that they and other countries in the world lost tens of billions of dollars because of the failure to control an outbreak. Second, diagnosis. To diagnose new viruses, you need new technologies. We have already shipped a new, highly sensitive kit for this particular strain to dozens of countries, and dozens of states in the US, so that when there are suspected cases, and there have already been dozens of suspected cases in the US, all tested negative. None of you who've been to China have had it. Third, the importance of helping doctors. How do you diagnose it? How do you treat it? How do you respond if we need to put thousands of patients on breathing machines? And that's why the CDC cares for something called the Strategic National Stockpile. Within 12 hours, we can get emergency supplies for a man-made or natural disaster anywhere in the country, whether that's medications, vaccines, or other things. And fourth, vaccine. CDC has created the seed strain for this vaccine. NIH will do clinical trials with it. BARDA, another arm of the Health and Human Services Department, along with vaccine manufacturers, will make vaccine. And if we have to distribute it, CDC will distribute it. We did that in 2009 for the H1N1 pandemic. And as with many things in public health, some of the most impressive things are the things you never hear about. There were more than 320,000 shipments to more than 80,000 doctors of vaccine within hours of it being ready without a glitch. Because there wasn't a glitch, you didn't hear about it. But finally, I'd like just to tell you about our scientists at CDC. We've activated our Emergency Operations Center for this response because it's tremendous potential for harm. Today, 193 scientists are working in this area. At CDC generally, we have 3,159 people with advanced degrees. They spent 8 or 10 years after college getting an MD, a PhD, a veterinary degree, a dental degree. And I won't ask for a show of hands for this, but I'm sure that most of your salaries are more than their average of $119,000 a year. And really, all they want are the resources to protect you as well as humanly possible. All they want are the resources to go from the availability of technology to protect people and keep us safe, to applying that technology so that we're safer, our economy is more robust, and people can live longer. And one of the things that makes my job a little harder is that the ethos at CDC is very interesting. People are delighted if they save lives, and it's even better if nobody hears about the lives they save. Because that's really their approach. They just want to be able to do everything possible to keep Americans safe and healthy.
Thank you, Tom.
You know, Mike, this is a wonderful example of CDC's amazing contributions to public health, and just one of many, and also a good example of how across governments and across the world this collaborative spirit is very much vigorously alive and needs to be. It also is a good example of how perhaps if we can take a longer view, science might get us into a new place in terms of the pandemic after this one and the one after that. And I just wanted to mention there's a lot of excitement now about the potential by very good immunology and very good virology to develop a vaccine that would actually work on all influenza viruses. It would work on the seasonal ones that you now have to get your shot every year. It would work on the emerging pandemic ones as well. Already in clinical trials with a lot of promise. Basically, the idea is to build a vaccine that encourages your immune system to go after the stem of that protein called hemagglutinin, which is generally invariant from virus to virus, as opposed to the top part of it, which varies a lot from strain to strain, because that kind of stem antibody would be protective broadly across influenza. I think with appropriate pushing hard on this, and again, there's a resource question there, we might find ourselves in 5 years, or at least 10, in a situation where this ever-present cloud on the horizon of the next influenza pandemic might begin to dissipate because we actually know how to immunize people ahead of time instead of having to quickly rush around, as we are now doing for H7N9, and try to get a specific vaccine ready for that one that just popped up somewhere in the world.
Francis, the President of the United States, and I know you were involved, recently made an announcement about investing and focusing on the brain.
Yes.
We've talked about polio, we've talked about AIDS, talked about SARS and many of these influenzas. Okay, one of the concerns when you look at projections today surrounds Alzheimer's.
Oh, yeah.
Our success in extending the length of life obviously has challenged us in this area. I'd like to just show a very short video that drives this home.
We had 3 children, 2 boys and a daughter. We were all very close. As a person, he is kind and generous and has absolute integrity. Probably 8 years ago, when I began to realize that his business judgment was not as good as it has always been, and some little glitches began occurring, and he would begin asking me questions over and over again. And I would get cross when he'd say, "When do we go to the market?" And I'd say, "Tomorrow." 5 minutes later, "When do we go to the market?" "What did we have for lunch, honey?" 2 minutes later, "I think I'm hungry. We haven't eaten lunch, have we?" The doctors initially said, "Well, he might have some Alzheimer's. We're not sure. You can't tell for sure. The only way you know for sure is by an autopsy." Of course, I wasn't ready for that yet. The transition from being a wife and a love to a mommy and a caregiver. Because when Leonard developed Alzheimer's, I lost my best friend, my love, my comrade, my business companion. I lost it all in one man. That's the most difficult part.
So Francis, we look at the numbers, hundreds of billions, trillions of dollars of cost, something that could affect every single person. It's not a virus from that sense, maybe. What is the president's announcement and what are these efforts on the brain mean in this area?
Well, you can't watch that video without being moved, touched, affected, and yet in this room, I am sure there are stories like that at almost every table of people who have family members who've been affected by this dreadful disease that robs people of their golden years and takes away the thing that probably we most cherish, which is our thinking, our minds. And this has to be one of the highest priorities that you could imagine for medical research. And yet Alzheimer's has been a very challenging and difficult problem to try to understand. And oftentimes by the time the diagnosis is made, we can see the disease has actually been present already for maybe years or even decades. And already we're way behind in terms of coming up with an intervention. We are determined as a worldwide research effort, and NIH is highly engaged in this enterprise to change all that. And I would say that after quite a few decades of frustration with Alzheimer's, trying to understand what is the molecular basis of this disease and how could we intervene, there is a great deal of momentum that has developed over the last 5 years. We've discovered in the genetic arena factors that seem to play a role in risk, going beyond the one we knew about for quite a while, ApoE, to now about a dozen of these, each of them pointing towards pathways that we didn't know were involved in the disease. Immunology is in there, which we didn't quite know before. Lipid metabolism is in there. With this remarkable ability to take a skin biopsy from someone and turn it into a induced pluripotent stem cell, an iPS cell, and then cause that cell to become a neuron. We can look and see, growing in cell culture, how is it that Alzheimer's is different from somebody who doesn't have that? And you can actually see differences in those neurons in the cell culture from individuals who are still walking around. And that gives you a golden opportunity to understand the cell biology and even to use this as a screen for new drugs without putting people at risk, but you're basically treating the disease in that Petri dish. We have an example of this repurposing, a drug that was developed for a type of skin cancer, a T-cell lymphoma, a drug called Bexarotene, which somebody thought, well, let's just try that for the mouse model of Alzheimer's disease. And in 72 hours, the amyloid, which is the signal peptide that turns up in the brains of individuals with this disease and in the mouse model, disappeared almost, a dramatic result, and the mouse behavior got much more normal as well. And there is now a trial just getting started with that drug in humans, as there are perhaps a dozen trials that NIH is supporting right now. So the excitement, the momentum is there, but this is going to be a long, hard pull. And the other thing we have certainly learned about Alzheimer's and Parkinson's and autism and schizophrenia is that we don't have the foundation of really understanding how the brain works to build this science on top of. We have a lot of work to do there too. And so what the president announced a month ago was a brain initiative, which is going to be a partnership between NIH and the National Science Foundation and DARPA, the Department of Defense's Advanced Research Project Agency, and a number of foundations, the Allen Institute for Brain Science, the Kavli Foundation, Howard Hughes, Salk, and some companies who are very interested in this as well. All of this being shaped into an exciting potential effort to lay out really much more specifically how it is that circuits in the brain work. We're pretty good at measuring the activity of single brain cells, and we can take scans of the whole brain, but we don't have information on all that complicated stuff in between. And you have 86 billion neurons up here in this most complicated biological structure in the known universe, and being able to sort out how that works is going to be a big challenge. So we're not talking about a year here, we're talking about a decade effort, but it's time to get started. Even in the face of difficult budgets, we are going to push very hard on this, bringing new talented expertise from nanotechnology, from engineering, from robotics, from computer science. This is a big data problem of the biggest sort, and from medicine, and see whether we could build that foundation upon which research on all of these brain diseases would be much more empowered. That's what this is about.
Yeah, there's a very important lesson here, I think, that addresses the issue of optimism, and it's this convergence now of technologies. A lot of comparisons between what's happened in cancer and what is now an opportunity in neurodegenerative diseases. But the real issue for cancer and a lot of the cancer progress was that we had something we could study. Mm-hmm. People would give us their tumors. That's not been an opportunity with regard to the brain until now, when we have tools that we never had before to be able to understand the brain in the human condition in real time. We don't have to wait for autopsy. So we're seeing imaging become increasingly more sophisticated so we can study the brain in ways we never could before. New technologies like optogenomics, and now the opportunity for what's called the transparent brain. So what Francis is alluding to is that there's a convergence of progress in multiple fields that are now being focused on this incredible public health problem that is devastating us from a physical and emotional point of view, and it's bankrupting us. So when we think about that opportunity and convergence, this is not going to be as long a trajectory as it's taken us in cancer. This is going to happen much, much faster if we wanted to.
Andy, thank you. I just want to go back and step back and thank James Watson was 25 years old when he co-published his study, when we talk about young investigators. Isaac Newton was 23 when he began inventing calculus. Marie Curie was 30 when she started studying radioactivity and already won 2 Nobel Prizes by the time she was 45. And Galileo was 22 when he began experimenting with falling objects. And as Pearl Buck has told us, the young don't know enough to be prudent, and therefore they attempt the impossible and achieve it generation after generation. And we're all aware in the last year or two that was brought home to us just the difficulty of dealing with pancreatic cancer patients with the loss of Steve Jobs, who created one of the greatest organizations in the last 200 years in Apple. I'd like to introduce you to one of these young investigators. He's the youngest panelist at the Global Conference. He was 15 years old when he won the grand prize at the Intel International Science and Engineering Fair. Jack Andreka, could you stand up, Jack? Hopefully you're with us today.
All right, Jack.
Someplace in the audience? No, not sure where he is. But here's a photo of Jack, and Jack created a test that detects early stage pancreatic cancer with 90% accuracy and at a cheaper cost than any test. The science, it's available to us today. As we look at the commitment of other countries, 2 countries that we're all aware of will be 2 of the 3 largest economies of the world at one time, India and China. They have made significant increases in increasing their funding. And as you look there at the United States, one of the reasons we've talked about the challenges of the United States is the unbelievable amount of resources that are being drawn away due to dealing with the gaining of weight in America that could be applied in biological research. What role the United States is going to play in the future, as you've heard on this panel, is going to be determined at this time. And as Nancy, Tom, Francis, and Andy have pointed out, it's not just an investment by the agencies, but it's a participation, and prevention and wellness is just as important as dealing with these issues. In closing, I'd like each of the panelists to kind of give us just a couple-second view as to what are the things we could do that you think would be most helpful with this group we have at the Global Conference in the next couple years in driving bioscience and the role the United States and other countries are going to play in the world. Andy?
Well, I think one of the things that happens at this conference that's almost magical is the networking and the convergence of ideas. So I told you that life sciences was going to change the entire course of the 21st century. Let me give you just one little sliver of that. The whole field of regenerative medicine, where not only do we eliminate disease, but we can actually restore health, restore organs. So one of the sessions at this conference had to do with 3D printing, and they produced an incredible chess piece in the process. Well, the most amazing 3D printer in the entire world is a pregnant woman, because we take one cell and she will develop that into a Francis Collins within 9 months. Think about regenerative medicine, stem cell biology, and all the discovery that's occurring by virtue of what Francis and others are doing. And then think of converging that with an independent activity that's going on to understand the process of being able to wed those together so that we can perhaps regenerate cardiac tissue, we could regenerate kidneys and reduce or eliminate the need for transplants or dialysis. What would that mean to our economy and to our healthcare costs? This is an unbelievable opportunity within our grasp. We've got great strategic plans. We may not have a very good business plan for this, and so we need to get to work.
Francis?
Let me take the 20,000-foot level. The strength of America, in many ways, since World War II, has been our investment in science, technology, innovation, particularly in the biosciences. Mike Milken will point out that that's accountable for more than 50% of our economic growth. We have the opportunity to sustain that momentum in remarkable ways with the talent and the scientific developments that are happening. And yet the rest of the world also has a serious intention of doing the same. But it isn't just about economics. It's about the health of each of us, about our families, our children, our parents, looking for a time where we can offer things for people who currently are stricken with diseases for which we have no answers, which frankly is most of them. As a nation, I think we will be judged by how it is that we respond to that opportunity and that responsibility. It is a bit of a tough time now, but I'll finish with my favorite quote from Winston Churchill, and there are a lot of them, which is this: if you're going through hell, keep going.
Nancy?
You're going to ask me to follow that. Okay. Here's a few thoughts that I have. If you think science is expensive, try disease. You know, the cost of disease in this country is going to bankrupt America. You know, the healthcare costs in this country continue to skyrocket, and until we can get Americans in better health, we will continue to have these types of problems. Investing in science, investing in translation of science, and programs that we, organizations like the American Heart Association and the partnerships that you see here today that we're conducting to help people be healthier will keep America at the forefront of innovation and at the forefront of prosperity and economic growth.
Tom, you're our cleanup hitter today.
We have to have a balanced portfolio. We have to invest in research to create the tools of tomorrow, but we also have to invest in programs to make sure they're used, because the best research in the world isn't going to save lives if it's not used. And we have so much more that we can do. We have so much that we are leaving on the table today that we're not preventing today. As a doctor, to me, it's painful to see. It's painful to see the cancers, the infections, the illnesses, the injuries, the deaths that happen today, that today we have the tools to prevent, and we're not doing. I'll leave you with a quotation from a wonderful public health leader of 100 years ago. He said, "Public health is purchasable. Within natural limitations, a community can determine its own death rate."
I think that ties into, once again, reinforcing probably the greatest achievement that we have as mankind has been, particularly in the last century, the extension of life and the extension of the quality of life. As we live in this century, the 21st century of bioscience, our efforts are to recommit our efforts, and we welcome all of you to join us. Thank you very much.